So alcohols basically are alkyl groups with an OH group. In this OH group is hydroxyl group. We have different types of alcohol. First is a primary alcohol. So primary alcohol is an alcohol where OH is attached to such a carbon which is further attached to only one alkyl. This is what we have done in alkyl halide. Then we have
Yes.
secondary alcohol. So what would that be? A secondary alcohol would be something that's attached to two different carbons, and a tertiary alcohol would be something that is attached to 3-degree
Three.
carbon or a tertiary carbon. So that's what a tertiary alcohol would be. So now, first is the general formula, which is CnH2n plus 1 OH. That's how we represent alcohols. And how do we prepare them? So preparation of alcohol is a very sensitive task as it revolves around having some enzymes and all. So the process is fermentation. So what is fermentation? Any ideas?
It has a equation for it. Hold on, let me look.
Sorry, what?
Mm.
Okay, so it's a chemical.
Ethanol is fermented, right?
I can't get that what you're saying. Chemical decomposition,
Ethanol is fermented, right?
but ethanol is an alcohol. So we are not talking about fermentation of alcohol. We are producing alcohol through fermentation. So chemical decomposition of substance by enzyme action.
Okay.
So that's how they are prepared. So glucose is fermented into ethyl alcohol and carbon dioxide. So glucose is C6H12O6 through fermentation. We have C2H5OH. CO. So what are the conditions required here? So conditions required here is the yeast. So it converts sugar to alcohol.
Okay.
It also catalyzes the reaction. In the temperature, whatever we use should be around 18 to 24 degrees Celsius because since it contains enzymes, so enzymes are denatured to a certain
Yeah.
temperature. So it can be approximately to 40, but not below, not above 40. So above 40
All right.
will cause denaturing.
But what's the actual temperature?
So 18 to 24
All right.
denaturing of enzyme. And then also one of the conditions is prevent oxidation. So we have to kind of avoid oxygen.
Ox.
So this should be in the absence of oxygen. These are some of the conditions that are used to prepare alcohol. However, a synthetic technique could have been simply hydration of alkene. Do you remember what was it?
Yeah, the use of hydrogen to make alkenes.
Alkenes are unsaturated hydrocarbons, and we can add water to them. So what we have is this double bond broken up and converting it to an alcohol. So that's
Yeah.
basically a synthetic technique to prepare what? To prepare
Alcohol.
alcohol. This is what we have done in alkene. Do you remember the
Okay.
conditions?
Yes.
Conditions are phosphoric acid, 300 degrees
Sorry?
Celsius, 60 ethanol. These were the conditions for this reaction.
Yeah.
Number three, okay, that's not now included, so let's leave that. Okay, so chemical reactions of alcohols. So first is reaction with group 1 metals, alkali metals. We'll take it an example of Na. So if I'm having an alcohol and I react it with sodium, so it forms sodium ethoxide. So sodium ethoxide test is also done for any compounds with OH. So it's a test to detect OH group. So now we don't write hydrogen in atomic form. So for that purpose, we'll write it this way. Let's
All right.
I'm having a diol. So a diol would be something like this. And I reacted with sodium in excess amount. So what do I have? Is any suggestion?
That's a diol, right?
What's the product? So it would be NaO,
Di is ethoxide sodium.
with 2 hydrogen. So yes, you were right. It would be sodium di.
Sorry.
So what if we have 3 alcohols? A triol, sodium in excess. So we'll have NaOCH2, CH4Na, CH3, ONA, and then we'll have 3 upon 2 H2 because each sodium was giving us 1 hydrogen, or each
Mhm.
OH would give us 1 hydrogen. So we'll write it as this. Then, second reaction. This would be dehydration of alcohols. So what do we have if we dehydrate an alcohol?
We'll remove the hydrogen. Water.
And then what would we do? So that would be an alkene. That's how we used to prepare an alkene. So concentrated sulfuric acid can be used at 180 degrees Celsius to dehydrate it, or we can use aluminum oxide at 300 degrees Celsius to dehydrate.
Okay.
So this elimination This is an elimination reaction. So all elimination reactions follow Zev's rule. That's the reverse of Markovnikov. So for example, if I have something like this, so if I dehydrate it, so there are two possibilities for a double bond. It can be formed here and it can also be formed here. So which one would be correct? So the answer to that is the correct would be that hydrogen is removed from that carbon which already contains less number of hydrogen atoms. So the major product would be something like this.
Okay.
So that's bute to ene with water.
Hmm.
However, the minor product can be the other thing. It can be CH2, CH2, CH3 with water.
Bute
So
one
that's bute one
butene.
minor. So okay, let's give you a question. So what would be the product in this case? We dehydrate this.
Hold on. वो नीचे CH3 है
Yes,
sir.
yes.
Okay. CH3C and then we'll add a double bond and add CH3 and CH3.
Okay, just send me the picture.
Okay. Sorry, I didn't add the plus sign between H2O and the reaction equation.
But why I don't see any hydrogen removed from all of the methyl groups? We have removed OH, that's correct. But why is this hydrogen still there? So the question is that this would be removed, right?
Yeah,
Then this would take away hydrogen from either this or that, right? So if
yeah.
it takes away hydrogen from the upper side, so it could be something like this and CH3 plus water, or it can be something like this. Both are equally correct, both are acceptable. But you have drawn everything with CH3, CH3, CH3. Which is it? Do you get this?
Oh, yes, yes. I got confused.
So now what would be the answer here? They're all CH3s.
Hold on. Can you show the previous slide? Yeah, okay. Hold on.
So tell me one thing, how have you decided to eliminate hydrogen from the other carbon that's on the top?
Yeah.
You have actually made a double bond between this and that. How is this happening? This can't happen. So no dehydration here. Do you get this?
No.
See, the idea of hydration is that we take away OH
Mm,
with an H, right?
yeah.
And for that H, we decide which carbon we are going to attach up. So this OH is attached to CH2, right?
Mm,
So then this CH2 is attached to a carbon, okay, which doesn't have an hydrogen at all. So
okay.
how would you remove hydrogen from this side? Then you have selected this. So there was nothing attached to this or that, right? OH was not supposed to be attached here. OH was attached here. So how would we have a product?
Okay. All right. Got it.
So we can then I think that is all for alcohol. Then we
Sorry?
have I I said this is all for alcohol. Now what we have
Yeah.
is carboxylic. So we'll start it tomorrow.
Okay. Sir, are you giving any questions for this?